All right, so let's talk about triangles and the angles of triangles. So, a triangle is a polygon with three sides, and we can classify triangles by the sides and by the angles. When we classify by the sides, we want to classify it by how many congruent sides it has. So with no congruent sides, it's called scalene. If we have two congruent sides, it's isosceles, and with three, it is equilateral. So that's when we classify by the sides. When we classify triangles by angles, well, it becomes pretty obvious pretty quickly. If we have all acute angles, it's an acute triangle. If we have one right angle, then it is a right triangle. There's an obtuse angle, it's an obtuse triangle. And if we have three congruent angles, it is equiangular. And spoiler alert, if it's equilateral, it is equiangular. And if it is equiangular, it is also equilateral. It's probably why you haven't heard the term equiangular used before. But that's not going to be true in other polygons once we start looking at different shapes. So we need to be familiar with the word equiangular, which means all three angles or all the angles are congruent. So let's go ahead and classify this red triangle here. And the first thing we notice is that we have two congruent sides, which is going to make it isosceles. And then if you could see my protractor, which I've got out, you would see that the measure of this angle up here is 70, this is 55, and this is 55, all less than 90 degrees. So all acute, so we have an acute isosceles triangle here. But what about when it's in the coordinate plane? Well, we want to classify this triangle here by its sides, and then determine if it's a right triangle. Well, for the sides, we need to know how long the sides are, because if they have equal sides, we can classify it as scalene or isosceles or equilateral. And since we have coordinate points, we can simply use the distance formula to determine what the length of each side is. So actually, let's start green. And let's start with PO. So we've got -1 minus 0 squared plus 2 minus 0 squared, which equals -1 squared plus 2 squared, all under the square root. Now, we're just going to compare these, and a number under a radical is a number, so we can stop there. So now let's do OQ, because we had a feeling that PO wasn't going to match anything. So let's do OQ. I like to work with the zeros first because it's super easy. right, so radical 45 is my length of OQ. One more is PQ. So let's get this. So we got 6 minus a minus 1 plus 3 minus 2 squared. So that gives me 7 squared plus 1 squared. So 49 plus 1 equals radical 50. So you have radical 5, radical 40, and radical 50, which is going to make this a scalene triangle. Now we got to determine if it's a right triangle. Well, we know that if it's a right angle, the two lines that intersect to form a right angle have opposite reciprocal slopes. So flip the number over, change the sign. And looking at this, I'm thinking this angle right here is my highest probability of being a right angle, so I want to check it first. So I'm going to do the slope of PO. So the slope PO. So I got the change in Y over the change in X equals 2 over negative 1, or 2, but since we're just comparing them, so now let's do the slope of line OQ. So once again, we got the change in Y over the change in X. That's going to equal 6 over 3, or 1/2. So negative 2 over 1 is the opposite reciprocal of 1/2. So it is indeed a right scalene triangle. Easy enough. Well, let's do one more example. Together. So we're going to do side AB, and we're going to do 7 minus 0 squared plus 1 minus 3 squared. So 7 squared plus negative 2 squared. And we're going to do BC. And we get 1 minus 7 squared plus negative 1 minus 1 squared, which gives us negative 6 squared plus negative 2 squared. So it's 36 plus 4, which equals radical 40. Then we'll do AC. And AC we've got 1 minus 0 squared plus negative 1 minus 3 squared. So we get 1 squared plus a negative 4 squared. So 1 squared plus 16 equals radical 17, 53, 40, 17. No two are alike, so it is a scalene triangle. Now let's determine, is it a right triangle? So once again, this is my most likely culprit to be right. So let's do these two lines and see what their slopes are first. So we're going to do the slope of BC. So we get 1 minus a minus 1 over 7 minus 1 equals 2 over 6 equals 1/3. Then we're going to do the slope of AC. So AC is going to be -1 minus 3 over 1 minus 0, which equals -4 over 1. So that's not a right angle, but let's do our last one just in case that our diagram is really out of whack. So the slope of AB is going to be 3 minus 1 over 0 minus 7. So 3 minus 1 is 2, -7. So it is not a right triangle. It is scalene and not right. It was just asking us, is it a right triangle? So we can stop there. One more time, we're going to do it, but without a diagram. So that means we just got to do all three slopes and see what happens. So go ahead and pause the video, find the sides, determine what kind of triangle it is by its sides, and then is it a right triangle? All right, let's see what we get. So we're going to do AB. So we get 3 squared plus 3 squared equals 9 plus 9 equals radical 18. Then we get BC, which is 3 minus a minus 3 plus 3 minus 3 squared. Oh, we could have done this with the absolute value of the change in x, but we didn't notice it soon enough, but that's okay, because we'll get to the same place. So 6 squared plus 0 squared equals radical 36, which equals 6. And then we got to do AC. So we get -3 minus 0 squared plus 3 minus 0 squared so we get radical 18. Two of the three sides are the same, so it is isosceles. Now let's find our slopes. So the slope of AB so the slope of AB is 3 minus 0 over 3 minus 0. So that's going to be 1. Then let's Find the slope of AC, which is 3 minus 0 over negative 3 minus 0. I like to do the zeros first usually because it's so much simpler. We get negative 1, and 1 and negative 1 are opposite reciprocals of each other. So we do indeed have a right triangle. We can stop there. We don't need to do the third one because we established that it's a right triangle. Had we not done that, we would go ahead and do the third one. And let's do the third one just to practice. So let's do the slope of line BC. So we get 3 minus 3. So the slope, 3 minus 1 minus 3 equals 0 over 6. So the slope is 0. So we have a horizontal line. Interesting. All right, so let's talk about interior angles. So the original angles in a triangle, these that we typically already think of as the angles of a triangle, are called the interior angles. And they're just the angles in a triangle. But we take it a step further, and the angles that form a linear pair with the interior angles are the exterior angles. So if we extend out this line, the side of the triangle, past the triangle, so we can do that twice, right? But what we want to establish is a linear pair. We are not going to use this second one. We're only going to use one. That's what we have here. This is a linear pair. Linear pair, linear pair. So those are what we're going to use when we talk about exterior angles. And we remember that a linear pair is supplementary, meaning the measure of the angles add up to 180 degrees. Well, the sum of the measures of the interior angles of a triangle is 180 degrees. That's a whole lot of 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. Okay, that's interesting. But what about the exterior angles? We just mentioned them. And so the theorem says that the measure of an exterior angle of a triangle is equal to the sum of the measures of two non-adjacent interior angles. So what does that mean to us? Well, we know that the three angles inside a triangle, and let's just call this one right here C, the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. Well, we also have a linear pair here. So the measure of angle C plus the measure of angle 1 equals 180 degrees. Well, if the measure of angle B plus the measure of angle A plus the measure of angle C equal 180 degrees, I can substitute, so the measure of angle A plus the measure of angle B plus the measure of angle C equals the measure of angle C plus the measure of angle 1. Well, I can subtract the measure of angle C from both sides. So I'm left with the measure of angle A plus the measure of angle B equals the measure of angle 1. So this is going to equal this plus this equals that. So whatever A plus B are, it's going to equal the exterior angle on the other side of the triangle. Let's look at a couple of examples that will hopefully help. So we're going to find the measure of angle JKM. So J to K to M. So that's this one out here that we're going to find. And we know that the exterior angle, angle JKM, is equal to the sum of the measures of the two non-adjacent angles. So that's angle J and angle L. So 2x minus 5 is going to equal x plus 70. And then we just got to find x. So x equals 75, but we got to find the measure of JKM, so we got to plug it in. JKM is 2x minus 5. Let's go ahead and substitute in our so 2 times 75 is 150 minus 5. So the measure of angle JKM equals 145 degrees. So why don't you see if you can find the measure of angle 1, pause the video, find the measure of angle 1, and then restart it, and we'll see how you did. All right, so what can we do? Well, we know that these two angles is going to equal this angle. That's our exterior angle theorem. So 3x plus 40 equals 5x minus 10. So let's just do our handy dandy algebra. Put the x's by itself. And we're going to find out that x equals 25. Well, we're not done yet. So now we got to plug it in. So 3x equals 75, 3 times 25, plus 40. And let's plug it in here. 5 times 25 minus 10. 5 times 25 is 125. Minus 10 equals 115. So it is indeed true. But we're looking for angle 1. So we got to do 180 minus 115 equals 65, which is the measure of angle 1. And we are done. All right, so our triangle sum theorem says that all three angles add up to 180 degrees. And a corollary is something that is true based on our theorem information. So it's a shortcut on the theorem. And so if all three angles of a triangle add up to 180 degrees, and we have a right triangle So one of those angles is 90 degrees. The two acute angles are going to be complementary. So if the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equal 180, and the measure of angle 1 equals 90, make myself a little more room here. So 90 plus the measure of angle 2 plus the measure of angle 3 equal 180. I can subtract 90 from both sides and get the measure of angle 2 plus the measure of angle 3 equals 90. So we know, because we're just skipping a step by taking the 90 off of both sides at the very beginning, that we can find the measure of the acute angles by adding them together and equal them to 90. So here we have a right triangle. We got two acute angles to find. So we can just set their sum up to 90 and solve. So we're going to combine like terms. And we're going to get the x by itself. So 3x equals 96. Divide both sides by 3. X equals 32. So 2 times 32 is 64. And then 32 minus 6 is going to equal 26. And 64 plus 26 equals 90 degrees. We're good to go. So we'll look at two more problems and then we'll be done. So we're putting new doors in a building and we want to use right triangles. Don't ask me why. For each door, the measure of one acute angle in the triangle is twice the measure of the other. Find the measure of each acute angle for one door. So let's draw a diagram of a right triangle. And let's look at this. The measure of one angle is twice the other angle. So the other angle is some number, and we're just going to call that number x because we don't know what it is. That's going to make this number 2x, and we know 2x plus x equals 90. 3x equals 90, so x equals 30. So one angle is 30, one angle is 60. 30 plus 60 is 90. We know we did it right. We're good to go and move on. Next one, we're putting in windows in a new house, and we're going to use right triangles for windows. Okay? We want the house to stand out. For each window, the measure of one acute angle in the triangle is 1.5 times the measure of the other. So once again, let's draw a right triangle. 1.5 times the measure of the other. The other is, we don't know. So let's call it x. So we have x, and we have 1.5 times that. So once again, we just set it up. Their measures go together. When summed up, equal 90 degrees. Combine like terms. Divide both sides by 2.5. So x is going to equal 36. And then 1.5x is 1.5 times 36, or 54 degrees. We are done.